All right, so we're back. Now it says the formula d equals 16 times t squared gives the distance in feet that an object falls from rest in terms of the time t that has elapsed since its release. Find the distance d in feet that an object falls in t equals 24 seconds. Well, okay, well that means we're going to have to plug in 24 here. So that means, guess what? There's some big numbers we're going to have to multiply. So d equals 16 times 24 squared. Okay, well, let's go ahead and start multiplying. 24 times 24. 4 times 4 is 16. Carry the 1. 2 times 4, that's 8, plus 1, that's 9. Now here we have 2 times 4. Well, we don't have anything there, so 2 times 4 is 8. 2 times 2 is 4. Now we add, so carry down 6, 17, 5. Okay. Now we have to multiply that by 16. And so we take times 16. So 6 times 6 is 36. Now that's going to be 6 times 7 is 42, plus 3 is 45. 5 times 6 is 30, plus 4 is 34. Now we're not going to have anything here, so now we have 1 times 6, 1 times 7, 1 times 5, add 6 and nothing is 6, 5 and 6 is 11, carry 1, that's 11, 12, carry 1, and that's 9. And so the distance is equal to 9216, and it's feet. So that is our distance the object falls in 24 seconds. Okay, so that's how far it falls. So if you think about that, that's quite a long ways in 24 seconds. So, that's the speed of gravity is, 9.8 meters per second squared, and you'd have to do all the conversions to feet per second, but I think it's about 32 feet per second squared. So that's where we're getting this at. Okay. What about this one? So now we're on Kelvin. Before we were on degrees Fahrenheit and degrees Celsius. This one's degrees Kelvin, or just a Kelvin scale. There's no degrees with it. The Kelvin scale of temperature is used in chemistry and physics. Absolute zero occurs at 0 Kelvin. And so, that's where everything stands still. There's no molecules moving. There's zero kinetic energy. And then water freezes at 273 Kelvin and then boils at 373 Kelvin. Do those numbers look familiar? Well, remember, water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius. And so it looks like the difference is to get to Kelvin from Celsius, we just have to go and from 0 degrees, we had to add 273. So that's how we would get that. And 100 plus 273 gives us 373. So it's an easy way to get from Celsius to Kelvin. But to change Kelvin temperature to Fahrenheit temperature, though, we have to use the following formula. Okay, so it's a little more complex. And so what they want us to do is use the formula to change 248 Kelvin to degrees Fahrenheit. Okay, so we just have to plug in that. So Fahrenheit equals 9 times 248 minus 273 all over 5, and then at the end we add 32. All right, well, what do we do here? Well, we take the larger 273 minus the smaller 248. Now we have to carry, so that's a 6, that's 13. So 8 plus 5 is 13. 6 minus 4 is 2. So that gives us a negative 25. All right. Now again, I'm looking here and I say, hey, 25 divided by 5, well, that's pretty easy to do. That's just going to be, now I'm going to change color because otherwise it'll look like I'm making an 8. 5 goes in here once, 5 goes in here 5 times, and it's a negative still, so we'll go ahead and put that negative there. And so now I just have to take 9 times the negative 5. Well, 9 times negative 5 is just negative 45, then plus 32. Well, again, we're going to take 45 minus 32. 5 minus 2 is 3. 4 minus 3 is 1. And we take the sign of the larger, and so we get a negative 13 degrees Fahrenheit. Okay, and so that's the temperature of 248 Kelvin. Okay. Now, could we have gone the other way? Yeah, we could do that. We could take 25 times 9. 9 times 5 is 45. And it's going to be 18, 19, 20, 21, 22. And so now we have 225 divided by 5 plus 32. And again, that's a negative. And so now we take 5 into 225. Well, that's going to be a 4. That's 20. Subtract, we get a 2. Bring down our 5. That's 5. That's 25. Subtract that 0. And there we got our 45, which is what we have right here. And then we add that to 32 and we get a negative 13 again. So you can go about it the long way, but if you ever see a shortcut like this that you can do when it's multiply and divide only. Now if you had an addition in here somewhere, that wouldn't work. But if you have that just divide and multiply only, then you can do that. Okay, so that's what we get for that one. All right, so what about here? A ball is thrown vertically upward. Its velocity t seconds after its release is given by the formula v equals v naught minus gt. Again, these are just variables. So, they're going to tell us what each of these variables are equal to, and then we just have to plug in what they are. Well, v naught is the initial velocity, g is the acceleration due to gravity, and v is the velocity of the ball at time t. So we know that time t, gravity, and initial velocity, and then that's the final velocity. So it says the acceleration due to gravity is 32 feet per second, which is 32 feet per second squared. Now, if the initial velocity of the ball is v naught equals 470 feet per second, find the speed of the ball after 4 seconds. Well, v is equal to v naught, which is 470, minus g, which we said was 32, times t, which we're saying is 4. Well, we just have to here take 32 times 4. 4 times 2 is 8. 3 times 4 is 12. So that's going to be 470 minus 128. Well, 470 minus 128. Well, here we'll borrow, that's a 6. That's 10 minus 8 is 2. 6 minus 2 is 4. 4 minus 1 is 3. And so that's going to be equal to 342. And again, we're back to the velocity, so that's going to be feet per second. Okay? So that would be our velocity after 4 seconds of throwing the ball upward. Okay? Again, all we did was plugged in the values they gave us, and then we did the arithmetic after that, and we did the multiplication, then the subtraction, and then we got our answer. All right, so that's all I have for this section.